Part 3 of this Python course, how to gather data from the web. Now in this recording, I will go over 5 main topics, which is 1, a basic introduction to how the internet works. 2nd, a couple of terminology items. We'll talk a little bit about the ethics. Then I'll tell you a little bit about the Python tools that you can use whenever you would like to collect data from the web. And then finally, I'll tell you about specific topics, and this will be the bulk of today's recording, where we will go over some of the more detailed instructions that you would have to go through in order to collect data from a variety of different sources on the internet. So how does the web work? Now, I will not go into too much detail here, but having a little bit of an understanding how the internet works is essential in trying to understand how you can collect data from the internet. Now, whenever you open up a web page, and I have an example here of my own web page, you will see something that looks nicely formatted as such. A computer will see a website as a collection of code. More specifically, it will see it as a kind of a page that is set up using a particular structure that it can parse and understand in order to figure out what needs to be projected in what way for us humans to consume whenever we open it using a web browser. So there's this underlying skeleton structure that has all the information that a browser needs in order to project the website towards us. But it's important to understand that what we see is not necessarily the same as what a computer sees, because whenever we use programmatic techniques such as Python in order to collect data from the internet, we will have to work with this skeleton structure and not so much with what we're seeing on our end. And then what a browser does is it converts essentially that skeleton structure, that code structure, and it converts it into that nice representation that we see every day whenever we open up a website. The way that this conversion works and the way that a browser can understand how a particular piece of code should be projected on a website is by using 3 main components. And this is not a full-on web development tutorial, so there is other components, but essentially every website will consist of these 3 elements, which is we have some HTML. The HTML in this case is the skeleton structure that provides structure to the all the different elements. We have some CSS. CSS is used in order to provide the browser with the information with regards to how things are supposed to look, whether something should be small, whether something should be large, or whether something should be red or blue or green or whatever. And then finally, we have the JavaScript component, which is a scripting language in its own right that will enable dynamic things to occur on a website within a particular browser. So I have a good example here, or a basic example, I should say, where let's say we have this very basic website. And this very basic website just says, hello world, there's a white square. And whenever we click on the button, it will change the color of the background to blue. Now we can kind of reverse engineer the 3 main components that I just mentioned, the HTML, the CSS, and the JavaScript, in order to see what part does what in this particular example. So if we look at the HTML, we can see that we now see that skeleton structure that says, hey, we have a div that has some identifier. We say there that the text needs to be hello world, and it tells us that there needs to be a button below that, which will have the text change color. So that's the skeleton. Now the CSS links into that skeleton based on identifiers and classes that are assigned in the skeleton structure. For example, here the div will have an ID and the button will also have an ID. So we can use those to link those to CSS features, which could be, for example, here that we want the body of this app to be a particular color. We maybe want some padding in order to situate things at a particular position. And we know here that for the banner position, we have some information that we want the background to be white or whatever. And we also have some information for the button, the color, the size, and some formatting. Okay, so all of the formatting, that's all applied by this CSS here. And then finally, we have the JavaScript component, and the JavaScript component will take care of the dynamic thing that needs to happen whenever we click on the button. Because whenever we click on that button, we want the color to change. And we need some JavaScript code in order to take care of that. So in this case, we can again use the skeleton structure and use the IDs and classes in the skeleton structure to refer to different items. So we refer to the banner, which we want to change color, and we refer to the button so we can track whenever it gets clicked. And then we have some basic JavaScript code here that says that for this button, whenever it is clicked, execute this particular function and then change the color. So then anytime we click this button, that JavaScript will fire and it will change the color. And the way that the color is changed is by changes that are applied or different references that are made to the CSS sheet. And then the HTML one is the skeleton structure that has all the identifiers so that we can figure out what needs to go where, and so that we can assign JavaScript functions to different elements, and we can assign CSS styling to these different elements as well. So these three elements are what makes up for the majority of websites that you might encounter. And this information is relevant because whenever we now want to collect some data from a particular web page, we can use these three different elements to our advantage. We can use the fact that there is that skeleton structure that is used to link that with the CSS and the JavaScript, and we can use that to tell our Python code what elements we would like to collect and what we would like to do with these elements. And I'll talk a little bit more about that at a later point as well. Now, a little bit of terminology here. What I'm going to talk about is what I refer to as web scraping. But web scraping is slightly different compared to what is called web crawling. And the nuance here is small, as in, if you were to see this, you might think, well, that's just the same thing. But whenever you Google, you want to make sure that what we do is web scraping, which is we know which page we want to go to. We want to go to that page and extract, scrape some information from the page. A web crawler would be some form of an automated system, like a bot, that will move from page to page in a semi-autonomous way. A good example would be a Google bot. Like Google tries to index all the different web pages so that it can show them under search results. This is done through web crawling because the Google bot is not telling the scraper where exactly to go. It's just saying, go to a page, find all the different links, and then move to the next page depending on what you find. Obviously, these things are highly correlated. The web crawler will do web scraping on each of the pages in order to figure out where to go. But generally speaking, for our intents and purposes, we know what pages we would like to collect. And all we need to do is we need to tell Python to go to that page and then collect the data that we want from it. So that's primarily web scraping. And the second thing is that you will hear me say the word API quite a few times in the next slides. And an API, whenever I talk about an API, I'm still talking about a website, but I'm talking about a website that is designed specifically for computers to be consumed instead of a regular web page, which would be consumed by humans. So an API is a website for computers, if you want to think about it that way. And these are great if we want to collect data, because whenever there's an API available, we don't have to deal with all of that stuff I just showed you, all that HTML, CSS. We could just go straight to the point where we can get the information in a way that the machine can visually understand it without us having to parse it first. So just to illustrate how this would look like, let's say that we're human and we want to know the Bitcoin price. How we would do that is if we have some website in mind, we would go to the website, but otherwise we would open up some search engine and then we would type in Bitcoin price. And then we would try to find a website that we want, and then we would look it up, and then we go and we kind of mentally make a note of that number, and then we're done. Or maybe we take that number, we copy it into an Excel sheet, whatever. The way a computer would do it is they would use one of these APIs that I just mentioned. And the API would look something like this, which is still a URL. You still see right here that there is a URL, and you can open this up in your browser. The only difference here is that, one, the URL looks kind of funky. Like you can tell it's not a super easy to use URL for human purposes. And whenever we were to open it up, you will see that for humans, it's pretty hard to understand what this exactly means. Now, I added some formatting here to make it a little easier. If you were to open this yourself, you'll probably just see a blurb of text, and you probably have very little to no idea what is actually being contained in that piece of information. But a computer will very much like this format because it can just parse it. And if we say want to get this particular value right here, which is the price in pounds, we can just use the structure that is in this data structure and we just tell it, well, go 3 layers deep and then look for the pound symbol and then open that up, right? It's something that it can understand. So that's something that we always strive to find first before we go to websites, because these APIs are just going to be very easy to work with from a programmatic perspective. Now, before we dive into how to actually do this, how to actually program something up so that we can collect data from the web, there is a little bit of an elephant in the room. And the elephant in the room is that it's not always clear whether you're allowed to programmatically access a regular website and collect data from that website. And the reason that this is not always clear is because, well, there are some intellectual property rights that you need to be aware of. But there's also a more practical thing where if you create a bot that goes and scrapes pages and you just scrape many pages at the same time, then it might simply be that the server that is running that website is not powerful enough to keep up with that amount of traffic. Because maybe it only saw a couple people in an hour, and now you're here sending 10,000 or 100,000 requests in an hour to that website, and that might actually bring it down. And this is very often how other websites get kind of taken down, because people deliberately will try to flood a website with as many requests to the point where it becomes unavailable. And these generally are called DDoS attacks, which are on purpose, but we want to make sure that we don't do that by accident. We want to be courteous of the fact that like these websites are running on hardware and that hardware might have a limitation. So I have a couple of general rules that I always follow. Now these rules are not set in stone, but these are just my own kind of guidelines that I've established over the years that I try to live by whenever I do some web scraping, which is that one, I will always use an API whenever there's an API available. This one is easy because if there's an API available, you'll be better off using that API anyways, because it will save you a lot of time. Second of all, I'm always considerate about the frequency with which I were to collect data from a human website if there is no API available. And a good example of this would be to put some sleep statements in your loop so that it sleeps every second after it tries to scrape some data, so that it's not continuously pestering that website with traffic 100 times a second. And finally, and this is a tricky piece, but some websites are very vocal about them not wanting you to collect information from their website. In those cases, I would be extra careful because if they're just a normal website and they don't make any explicit statements about it, then, well, that's one thing. But if this website is literally telling you, hey, stop collecting data from our website, it's worth kind of double checking whether this is really worth it in order to go through with this, because you might run into some problems where they might try to block your IP or they might try to block your account or whatever. If you look all around on the internet, you're going to find a lot of conflicting recommendations and advice. There has been a relatively recent court case involving LinkedIn and another third party that ended up favorable in favor of our ability to collect information programmatically from public websites. So in that sense, we're mostly in the clear, but still it's always good to make sure that we're doing everything in a polite and considerable way. And the final thing is also that if you do collect data, I'd be very careful with sharing that data with third parties, because there's one thing if collecting that data for your own research and then kind of just keeping it on your own computer and just running it. There's a big difference between that and then actually taking that information and just putting it out there. Now, if it's heavily processed, that's a different thing. If you use your paper or you write your paper based on data, but you processed everything and you just make the final data set available, that's different than if you just make your entire raw data set that you've collected available to everyone. Because at that point, if a website, for example, has advertisements and they're relying on these advertisements to keep that page running, if you are providing a third-party way of accessing that information, then they might lose out on a lot of revenue. So you need to be a little bit considerate of that and don't share any information without the explicit consent of the owner of that information. Having said that, I generally would encourage you to not get too hung up on this. Just be aware of it and use common sense. But I wouldn't go as far as saying, well, you cannot scrape anything, because there's always a little bit of a risk. Because I feel like as long as you do it in a responsible way, you can web scrape and they probably won't even notice it. You just use it for your paper and everyone will be perfectly fine. Okay, so tools. We've now decided that we are going to scrape some data from websites and we're going to use Python. There's two third-party non-Python specific tools that are useful. The first one just comes with the Chrome browser. So if you already use Chrome browser, you already have this set up, and it's called the Chrome DevTools. And the Chrome DevTools is amazing. Chrome DevTools allows you to essentially reverse engineer a website straight from your browser. And the way you would open it up is you would go to a website using the Chrome browser, and then you would click Control-Shift+J. You could also click F12, and then essentially what you will see, a little window pop up, and it might either be a separate window or it might just open up at the bottom depending on your settings. And then what you can do is you can essentially go through the HTML structure of a website to figure out exactly where all of the different elements are located. One thing that's useful is if, for example, if I wanted to know specifically where this subtitle here is located on my own website, I could right click on that element in Chrome and then click Inspect. And then what it will do is it will essentially move the cursor in this window all the way to where that exact element is located. So if I wanted to collect my title, I could go in the browser, I could right click and click inspect, and then I would know here that this is the information that I might be able to use to tell Python where I want this information to be retrieved from. I will tell you a little bit more about CSS selectors, but just know for now that sometimes when you want to collect a piece of information from a website, it can be pretty hard to figure out a reliable way to tell Python which elements you do want and which elements you do not want. You can build complicated CSS selectors by just trying to understand how the website works and building them yourself. But if you've never done any web development, this can be a little bit of a bridge too far. Fortunately, there is a tool, and it's a Chrome extension. So if you go to the URL that's provided here, you can install this into your Chrome browser. And this Chrome extension allows you to go to a website, open up this selector gadget Chrome extension, and then you can just click on the items that you do want. They will turn green or yellow, as you can see here. And then if something else turns yellow that you do not want, you just click on it again, and then that will turn it red so that the selector gadget knows that that's not what you want. And then it will automatically try to create a CSS selector, which is kind of like a roadmap to tell Python how we can get to that particular information and ignore all the other information. So in this case, if I just wanted to get my interests, I would select those. I would make sure that anything else is not selected like this. And then it will tell me right here what I need to put into my Python code or any other code for that matter that will use CSS selectors. So this can save you a lot of hassle if Chrome DevTools is not up to par on your particular website. Now, when it comes to Python, there are three main packages or three main libraries that are good to know. And if you know all of these three, then you're set for essentially any website, which is the first one is the requests package. And the request package will just allow you to, in your Python code, say, hey, I want you to retrieve the HTML and everything else from one particular URL. There's other ways to do this, but the request package has a lot of automation built in so that you don't need to worry about pages that break down or pages that are very slow. It will take care of all of that for you, and that's convenient because then you don't need to worry about it. Now, whenever you use this for an API, then request is all you need, because you open it up in request, you say this is a JSON and an XML file or whatever, and then you're good to go. Now, if you're opening up a human's website, then as I showed you at the very beginning, you now get this whole blurb of HTML and CSS and JavaScript, so you might have to do some parsing. And the parsing will essentially take that entire piece of text that has no context and no structure by itself if you just download it, and it will try to reverse engineer what that structure is. Almost like a browser, but then all within Python. And then once we've understand and once we've parsed the structure, we can then use these CSS selectors and what have you in order to select certain points or certain parts of that HTML that we would like to extract. But we have to do that intermediate parsing step. And we can do this using one of two libraries. For our intents and purposes, I recommend to use a partner package to request, which is called the requests HTML, which has parsing functionality for HTML built in. But if you want to do some more advanced things, you can also use a parser that's kind of standalone. And the one I would recommend is LXML. Request and request HTML are going to be fine for the far majority of websites. However, there are a couple of websites that are very heavy on the JavaScript. And these websites that are very heavy on JavaScript, they have a lot of dynamic elements. And this is a problem, and I'll show you an example later on where you might not be able to use request because you pull it, but then the data that you see in your website is not actually in the data that's being pulled from requests. And that is because that data might have been served through some JavaScript, and if that JavaScript is not executed, as is with whenever you use requests, then that data is just simply not going to be there. In those cases, you might have to resort to what they call browser automation, which is you can use a tool that is called Selenium, and then you have different bindings, and the bindings we use is for Python, that will allow you to use Python code to control your Chrome or Firefox or whatever browser you want to use. And at that point, anything you see in the browser is accessible through you via Python, because it's literally controlling the browser as you see it. That is a lot slower, but it's always kind of a last resort. If you really cannot get the data using requests, then you can use Selenium with Python, and then that will near guarantee that you can collect the data that you would like to collect. It just might take a while in order for that code to finish. So now I have specific code examples for 4 different scenarios. And these 4 different scenarios will cover almost anything that you might encounter whenever you try to collect data from the web. The first one is how can we interact with the most convenient situation, which is the availability of an API. Then second, an API is not available. How can we then go and web scrape a page, deal with the HTML, parse the HTML, deal with CSS selectors and the like. Then the third one is what if there's these JavaScript elements? How can we use Selenium in order to deal with that? And then finally, I'll give you a brief kind of a pointer as to a technique that I like to use a lot as well that can save you a lot of time. And I'll quickly show you an example on how you can reverse engineer HTTP requests so that you can almost create APIs or use APIs that are not necessarily very well documented. How can we use an API? Well, the basics of an API is that an API is a URL, and you can open that URL up using a browser, but you can also open that URL up using Python, particularly using the request library. And that URL will have parameters in it. And these parameters are our way of telling the system that we're communicating with what information we would like it to return to us. So for example, if we think about Bitcoin, we might have a cryptocurrency API, but we want to tell it that we would like to get the price of Bitcoin. So then we would it would have a coin parameter and we would say coin equals Bitcoin, for example. And then what will happen is if we do that well and everything goes through as it should, then what we end up with is something that we get in return. And what we get in return will be machine readable. And machine readable means is that without any parsing on our end, we can just put that into our Python code and it will be able to understand how that data is structured. There's generally 2-3 main types of this machine readable formats. The most common one and the most preferable one is going to be JSON, because JSON, whenever you load that into Python, it will just, you can use it as if it's a Python dictionary. So if you know how to navigate a dictionary, you know how to navigate JSON. You have XML, which is also structured, but it's slightly harder to work with. And then sometimes it's just literally plain text, where if you have a very simple API and you say, I want to get the price of Bitcoin, all it might return to you is simply a number. So then there's no need for JSON or XML. It's just going to be the number. It's going to be plain text. So how would this look like in Python? API requests you always make using the request library, as the name suggests. And then what we would specify is we would specify an endpoint. The endpoint is essentially the base URL that we would like to communicate with. And then we will specify the API parameters. These is generally referred to as the payload. So here we have our endpoint for the CoinDesk API in order to get historical prices, the closing price. And we can add some parameters to get some historical data that starts right here and that ends right here. So we get 4 days of data roughly. So that payload, in this case, is just a dictionary file. And then requests can say, or we can say requests, make a get HTTP request, use that API endpoint, and then provide the following parameters. Requests will take care of combining the API endpoint and the parameters into something that's usable, so we don't need to concern ourselves with that. It's all taken care of automatically. We can run this, and then we can also print out the URL so that we can inspect what it's actually doing in the browser by doing res.url. And then finally, because this will return a JSON file, what we can do is we can tell Python, or the request library rather, that, hey, this was a JSON format, so interpret it as if it's a JSON format. So we do res.json, and then from that point on, we just have a Python dictionary, and we can get the prices that we would like out of that dictionary, just like we would with any other Python dictionary. So as you can see, it only took us maybe 3-4 lines of code in order to get the data out of the API and then just parse it into a Python object that we can now use without having to concern ourselves about web scraping or anything. Let's say there is no API available, and we have to resort to scraping the web page. At that point, the first couple steps are going to be identical to how we would interact with an API, because if we do web scraping, we generally have 4 steps, which is we need to figure out what the URL is. We need to retrieve the data, and we will use requests for this. We have to parse the HTML, and we would then have to extract the information from that HTML structure once we've kind of parsed that HTML so that we can end up with the information that we would like. These first two steps of figuring out the URL and getting the data from the URL is exactly the same as how we would do it for an API. The only thing is when we do these first 2 steps with an API, we're going to be done. But if we do that with the regular website, then we still have to deal with the fact that this is HTML and not something that we can easily parse. So we would have to add step 3 and 4, which is to parse the HTML, and then use CSS selectors to obtain information from that HTML structure. So just to show you that this is the same for a website, let's say we want to scrape my own website. So we use request, we specify the URL. There's no parameters here because we're dealing with a regular website. And then we would get this, but then we turn out with this blurb of kind of hard to read text, which is the HTML. So we need to parse it. Now you can parse it using either the request HTML library, which is what I would recommend because that kind of is the easiest way to get this going. Or you can do it using a HTML parser such as LXML. And then you can do that, and it's right here. If you use request HTML, that already has requests built in. So you don't need to use request separately. You just use request HTML. You specify an HTML session, and then you say, get this particular website, just like you would with requests, but then with request HTML. And then what we'd have to do is it would parse everything as if it's a browser. And then we can refer to the HTML structure in order to refer to information that we would like to retrieve. Now, the easiest way, generally speaking, in particular for modern websites, is to use what we call CSS selectors. CSS selectors are nothing more, nothing less than the way that a browser will assign formatting to a particular element. So for example, we have a very basic website here. We have a button that says click me, and it doesn't do anything because it's just a simple button. And if we were to look at the HTML, then what we will see is we will see that it says button right here, and it has an ID value. This ID is how we can use CSS to apply that CSS to this particular button, because we need to figure out a way to link these two together. So we have given this button an ID and we called it click me. And then in the CSS file, you will see that we now apply all of this different CSS to this one button, because we look and here you see this little hash icon, that little fence icon that says click me, that will tell look for the ID click me, and then apply these formatting things to it. Now, we don't care about the formatting for our intents and purposes, but we can do the same thing using Python and request HTML and say, hey, we would like to get the text out of the button that has the ID click me. And then that way we don't need to do anything weird with regular expressions or anything. We can just use the logic, the structure of the HTML file that it uses internally for this formatting, and then we can use that in order to extract the information. So let's say, for example, we were to get this CSS selector from our website. We either do it by inspecting, using a Chrome DevTools, or by using the selector gadget. And then we would just simply put that into our request HTML code by saying here, we would like to take that result that we've obtained. We would parse it as HTML, and then we want to find, and then this is where we would put in our CSS selector, which is that kind of that path in order to get to that particular element. Now, the syntax of a CSS selector is pretty involved, and these can get pretty complicated, but in essence, there's a couple things you need to know. First, whenever something has a class attributed to it, so you look something up and it says class blah, 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 then you will have to put a dot in front of it in order to make the CSS selector so that request HTML knows that this needs to look for a class. If it has an ID value, then you need to put the hash mark. And if you just want to look for an element, such as a button or a paragraph or a span, then all you would do is you just simply put the name of that element, and you don't need to put either a dot or a hash mark in front of it. And then you can also combine multiple of these conditions together in order to say, well, I want you to look for this particular object or element, and then within that element, I want you to search for some other element. So you can change this together. So in this case, for example, we have a CSS selector here that says look for a div. And then within that div, look for a paragraph element. And then within that paragraph element, make sure that you only get the ones that have a class, because of the dot that has a class title. And then this might return multiple objects, or it might return one object depending on the website. I have a link here with all the details on CSS selectors if you want to look that up. There's a lot to it, but once you kind of get the hang of it and you know how to use Chrome DevTools and the selector gadget, you can get up to speed with this pretty quickly. So that's what I show you here. You can open up the selector gadget, do the clicking as I showed you, and then just copy paste this into your CSS selector field. Or you can also, whenever you right click on an element in your Chrome DevTools, and then you click copy, and then it says copy selector, that will also make an attempt at copying the CSS selector. Although that might work sometimes, it also might not work other times because it has to make an educated guess. So just know that these are kind of a good starting point, and then you might have to do some refinements later in order to make sure that it works reliably for all the different information you would like to obtain. Okay, so just to wrap this up, if I were to put all these steps then into one big overview, then we would have step 1, get the URL. This might be easy because someone might give you the URL. You might have to collect the URLs. Step 2 would be to use request HTML to download that page and parse it into HTML. And then finally, you can use CSS selectors to extract information from that HTML structure. And then at that point, you're left with whatever Python data structure you want, and you can continue with your Python code. Now, there's 2 final things that I briefly want to talk about, which is if a page is very JavaScript heavy, then you might use request HTML. For example, here, I think I went to a website that has a lot of JavaScript in it, and I looked up what I saw, and I saw CEO approval rating, and I was like, well, great, let me put that into request or request HTML. And then I would run it, I would create the CSS selector, I would do all those steps. But then when I do that in the Python code, it is not going to actually show me anything. It's going to give me an empty result. You might think, well, I must have done something wrong. Maybe the CSS selector is not working. But you can double check and everything should work, but ultimately Python is not able to see this particular value. And the reason is because that value is being loaded into the page by using some JavaScript, and that JavaScript is not executing whenever we use requests, because that requires a browser in order to run and interpret that JavaScript code. So in that case, we're kind of stuck when it comes to request or request HTML. And at that point, we might be better off to either try a kind of a straightforward approach, which can only work for simple websites, which is request HTML has the ability to open up an invisible headless browser in the background and kind of execute the JavaScript code so that it ends up in the page. But that doesn't always work. And in particular, if it's a more complicated website, that tends to break. So the more reliable way would be to use Selenium. And then use Selenium with Chrome bindings so that you can control Chrome, your Chrome browser via Python, and then you can go to that page. And because the page is loaded and everything you see is available to Python, you can then collect that information that way. And finally, you might also be able to try to reverse engineer HTTP requests, because there might be an internal API that they're using that you might be able to kind of reuse for your purposes in order to collect the data without having to go through all that stuff of the JavaScript parsing. So I have an example here how you would use that with that invisible headless browser in request HTML. You would just have to add this res.html.render line here, and that will give it a fair attempt in order to load it. And you see in this case that worked, because now this information became available because it opened up a invisible browser that executed the JavaScript, and then that information was loaded into the page. And if we were to use Selenium, I don't have an exact example, but just to illustrate how that would look like, I have an illustration that I found on the internet that demonstrates how they automated the WhatsApp client in the browser. So you see here, they're just running some Python code, and that's automatically controlling the Chrome browser. So it says, well, click this button, send this, get this information, whatever. And you can always use that. We're not going to do much of Selenium in this course, but just be aware of its existence if you ever have a project for which you might need it. Now, the final thing that I want to talk about is what we call HTTP requests. And HTTP requests is a pretty advanced topic, in particular if you've never done any web development or backend development. But essentially, a modern website, and this is getting more and more prevalent, a modern website will generally have a structure, but they will not yet have the information in the structure, because the information will be dynamically loaded into that page without having to refresh the page using some JavaScript and some HTTP requests. So this is essentially the website using JavaScript communicating with some APIs in order to load data into the website. The benefit of this is that if you want to change something on a website, let's say you want to open up a new page or you want to switch to a different profile or whatever, it doesn't need to refresh the entire page. It can just say, hey, I want to replace these elements in the website, pull those out of the API and then replace those, and then everything is a lot quicker and more dynamic from a user experience perspective. If the JavaScript code can use these APIs, then if we can reverse engineer what these APIs are, we can also use these APIs in our own Python code and almost pretend like we are the website that's trying to retrieve that information. And this can be useful because if we figure that out, then we don't need to go to the website. We don't need to scrape the website. Then we can just use that unofficial kind of internal API. And it would load that API anyways if we were to get the page, but we just kind of skip that intermediate step of having to parse the HTML. And this particular website with the JavaScript, we can actually see that that's happening. There is a Chrome extension that is called Network Sniffer, and you can just download and look that up. And that Network Sniffer Chrome extension will essentially tell you all the different communication that a browser is doing kind of outside services. And we can see that in this case, if we do this for this Glassdoor page and we have that open up and we load the page and we wait for everything to load, we can see that it is indeed communicating with some internal APIs. And then we can try to copy these APIs, put these APIs in our Python code, and then we might be able to circumvent that problem entirely. Because then we just get nice JSON files, we don't need to do HTML parsing, and we're going to be done way quicker. The downside of this is that this is generally all undocumented. You have to figure this out. It might throw errors that you didn't expect. So it's a little bit of work to get that to work, but sometimes it's worth just checking whether there's an easy API available using this method, because it might save you a lot of time. So that was a lot of information. So what I recommend you to do is I recommend you take a break and move on over to the demonstration once you're back. I will show you a couple of very brief examples of how I would interact with the request HTML. And then once you're done with that, you can move over to the GitHub page and start working on the problems for this particular portion of the course.